The only code reference that can be found regarding the orientation of the ground prong is in the National Electrical Code 2020 Handbook, Section 406.9b, Cord and Plug Connected Equipment. It states that when cord and plug connected equipment is disconnected from the receptacle, the grounding conductor shall be the last to break contact and the first to make contact. However, this requirement does not specify which way the receptacle should be oriented. The argument that a ground-up orientation is more likely to cause the ground prong to lose contact first is valid, but it is important to note that this is a very unlikely scenario. The ground prong is typically longer than the hot and neutral prongs, so it is less likely to be pulled out of the receptacle by gravity. Additionally, most receptacles are designed to grip the prongs tightly, so it is unlikely that the plug will come out without the user intentionally pulling it out. Ultimately, the decision of whether to install receptacles ground up or ground down is up to the electrician. There is no specific code requirement that dictates which way the receptacle should be oriented. The primary concern addressed by Section 406.9b of the National Electrical Code is ensuring that the grounding conductor provides a safe path for fault current. This is crucial for protecting people and equipment from electrical shock and damage. The grounding conductor's role as the first to make contact and the last to break contact is designed to minimize the risk of a hazardous voltage being present in the equipment enclosure. When a cord and plug connected device is plugged in, the grounding conductor establishes a connection to ground before the hot and neutral conductors become energized. This ensures that any fault current will flow safely to ground, tripping a circuit breaker or ground fault circuit interrupter and energizing the circuit. Conversely, when the device is unplugged, the grounding conductor remains connected until after the hot and neutral conductors are disconnected. This prevents the possibility of the enclosure becoming energized if a fault occurs during the disconnection process. The National Electrical Code does not mandate a specific orientation for receptacles, acknowledging that both ground-up and ground-down installations can comply with the safety intent of Section 406.9b. The longer ground prong and the tight grip of receptacle contacts contribute to the reliable grounding connection regardless of orientation. Electricians consider various factors when deciding on receptacle orientation. Firstly, some prefer ground down for aesthetic reasons, believing it provides a cleaner, more visually appealing installation. Secondly, others favor ground up, citing the theoretical concern of the ground prong being the first to disconnect in a partially pulled out plug situation. Thirdly, accessibility for users, especially those with disabilities, can also play a role in the decision. Fourthly, the intended use of the receptacle and the type of equipment being plugged in may influence the choice. Fifthly, local codes or regulations might impose specific requirements, although this is uncommon. Sixthly, an electrician's personal preference, based on experience and training, often guides the decision. Seventhly, standardization within a building or project can ensure consistency and ease of maintenance. Eighthly, some manufacturers recommend a specific orientation for their product. The National Electrical Code serves as a comprehensive set of guidelines for safe electrical installations. It is important for electricians to be familiar with the code and to apply it correctly in their work. Section 406.9b is just one example of the many requirements in the National Electrical Code that are designed to protect people and property from electrical hazards. The National Electrical Code is regularly updated to reflect new technologies and best practices. Electricians should stay up to date on the latest changes to the code to ensure that their installations are safe and compliant. The National Electrical Code also provides guidance on the proper selection and installation of electrical equipment. Electricians should choose equipment that is appropriate for the application and install it according to the manufacturer's instructions. It is important to follow all safety precautions when working with electricity. The electrician should wear appropriate personal protective equipment and use insulated tools. They should also de-energize circuits before working on them whenever possible. The National Electrical Code is a valuable resource for electricians and anyone else who works with electricity. By following the code, electricians can help to ensure that electrical installations are safe and reliable. Understanding the underlying principles of electrical safety, such as grounding and overcurrent protection, is crucial for making informed decisions about electrical installations. Electricians should strive to develop a deep understanding of these principles to ensure the safety of their work. Electricians should also be aware of the potential hazards associated with electricity, such as electric shock, arc flash, and fire. By understanding these hazards, electricians can take steps to mitigate the risks and protect themselves and others. The National Electrical Code is not a substitute for proper training and experience. Electricians should complete a qualified apprenticeship program or other training course to learn the skills and knowledge necessary to perform electrical work safely and effectively. Electricians should also continue to learn throughout their careers to stay up to date on the latest technologies and best practices. The National Electrical Code is a living document that is constantly evolving to meet the changing needs of the electrical industry. By staying informed about the latest changes to the code, electricians can ensure that their work is always safe and compliant. The role of the ground fault circuit interrupter is also very important and needs to be mentioned. Ground fault circuit interrupters, or ground fault circuit interrupters, are designed to protect people from electric shock. They work by monitoring the current flowing through a circuit and quickly interrupting the power if a ground fault is detected. Ground fault circuit interrupters are required in many locations, such as bathrooms, kitchens, and outdoor areas, where there is a higher risk of electric shock. Ground fault circuit interrupters should be tested regularly to ensure that they are functioning properly. The importance of arc fault circuit interrupters should also be mentioned. Arc fault circuit interrupters are designed to protect against fires caused by arcing faults. Arcing faults can occur when damaged or worn wiring creates a path for electricity to flow through the air. Arc fault circuit interrupters are required in many locations, such as bedrooms and living rooms, where there is a higher risk of fire. Arc fault circuit interrupters should be tested regularly to ensure that they are functioning properly. Electrical safety is a shared responsibility. Electricians, homeowners, and building owners all have a role to play in ensuring that electrical installations are safe and reliable. By working together, we can create a safer electrical environment for everyone. Proper grounding and bonding are crucial for electrical safety. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or ground fault circuit interrupter. Bonding connects all metal parts of an electrical system together, creating a low-impedance path for fault current. The National Electrical Code provides detailed requirements for grounding and bonding. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices interrupt the flow of current when it exceeds a safe level, preventing damage to equipment and reducing the risk of fire. The National Electrical Code specifies the appropriate size and type of overcurrent protection device for each circuit. Proper wiring methods are essential for electrical safety. Wires should be sized correctly for the amount of current they will carry, and they should be installed in a way that protects them from damage. The National Electrical Code provides detailed requirements for wiring methods. Electrical equipment should be properly maintained to ensure that it is functioning safely and reliably. This includes regular inspections, cleaning, and repairs. The National Electrical Code provides guidance on the proper maintenance of electrical equipment. Homeowners and building owners should be aware of the potential hazards associated with electricity and take steps to mitigate the risks. This includes educating themselves about electrical safety, inspecting their electrical systems regularly, and hiring qualified electricians to perform electrical work. The National Electrical Code is a valuable resource for homeowners and building owners. Always consult a qualified electrician for any electrical work. Electricity can be dangerous, and it is important to hire a qualified electrician to ensure that electrical work is performed safely and correctly. Qualified electricians have the training and experience necessary to install, maintain, and repair electrical systems in accordance with the National Electrical Code. Here are some additional points to consider when discussing receptacle orientation. Firstly, accessibility. Consider the ease of access for users, especially those with disabilities. A particular orientation might make it easier to plug in or unplug devices. Secondly, cord management. The orientation can affect how cords hang and how easily they can be managed. Consider potential trip hazards or strain on the cord. Thirdly, aesthetics. While not a primary safety concern, the visual appeal of the installation can be a factor for some individuals or projects. Fourthly, standardization. Maintaining a consistent orientation throughout a building or project can simplify maintenance and troubleshooting. Fifthly, specific equipment. Some equipment might have specific requirements or recommendations for receptacle orientation. Sixthly, local customs and practices. In some areas, a particular orientation might be more common or preferred due to local customs or practices. Seventhly, future considerations. Think about potential future uses of the receptacle and how the orientation might affect those uses. Eighthly, cost. In most cases, the cost difference between the two orientations is negligible. Ninthly, code compliance. Always ensure that the installation complies with all applicable codes and regulations. Tenthly, documentation. Document the chosen orientation for future reference and maintenance. It is important to remember that electrical work can be dangerous, and it should only be performed by qualified individuals. Always follow all safety precautions and consult with a qualified electrician if you have any questions or concerns. The National Electrical Code is a valuable resource, but it is not a substitute for proper training and experience. The electrician should continue to learn and stay up to date on the latest technologies and best practices to ensure that they are providing safe and reliable electrical installations. In conclusion, the decision of whether to install receptacles ground up or ground down is often a matter of personal preference, local practice, or specific project requirements. While the National Electrical Code does not mandate a particular orientation, it does emphasize the importance of a reliable grounding connection. The electrician should carefully consider all relevant factors and make an informed decision that ensures the safety and functionality of the electrical installation.